Hmm. Okay, yeah, this sounds good. So you basically want me to design something similar to like kayak.com or Google Flights, or something like booking.com, correct? Yep. And one of the first thoughts that comes to my mind for like these types of websites, are like there are a lot of like financial transactions involved, a lot of legacy data systems as well, especially with airline and air flight information. And I was just wondering, do we have any? Are we including all flights from all airlines, or do we have specific partnerships with certain airlines that we want to focus on? Hmm. Okay. So, just for the sake of assumption, let me know if I'm going too high or too low, but can we assume five partner airlines? Okay, perfect. Okay. And then from these airlines, I don't know off the top of my head, but it seemed there'd be a lot of flights per airline. Obviously, we might have a large airline and a collection of four smaller airlines. So I'm just going to give like an average amount of flights per airline. Usually for these big airlines, we also have like hub cities. So if we think about it from um, a global standpoint, let's say we have like 200 cities globally, right? They might be lower, might be higher, but per country, that I mean, if you aggregate all the countries, that seems like a modest amount of cities that we want our airlines to travel to. Would I be far off on that? Okay. Hmm. Okay. And just to make these calculations easy, I'm gonna assume like an average, like for these big cities, 5 to 10 flights per day. I mean, probably closer to that 5 flights per day per these 100 cities. Per per airline. I'm sorry. Yeah, five departures per day per airline per city. Yeah, like so. I'm considering like these 100 cities like a hub city, right? Um, yeah, yeah. Yeah, and the reason I'm saying like five is because like if you were to go to New York to LAX, right? You probably have five distinct times you could go, right? So even if you miss like your 9 a.m., like you could still go at 5 p.m. and you could go at 9 p.m. It might be a little too low. It might be closer to the 10 range. Mhm. Okay, yeah. So three. Okay, so 3 flights per airline per day per hub city. Okay. And then just for the specific functional and non-functional requirements of the program, I'm assuming because of the transactional nature and pricing information for flights, especially with customers buying tickets, we want the data to be highly consistent. Correct? So so Yeah, for example, like if you were to use like a similar service like buying movie tickets, there's like a little bit of automatic atomicity. I never know how to pronounce it. Yeah, atomosity. I'm sorry. Like where you have that. Yeah, the little bit of leeway, 5 to 10 minutes, where you're allowed to kind of hold off and disallow other people from buying the same tickets. So I'm wondering if we want this similar feature, or we're just designing a rudimental, a rudimental like securing airline ticket purchases and then aggregating the pricing, timing, and partnership data. Hmm. Yep. Okay. Yeah, because that can depend on that can actually help us make a little bit more money. If, like, for example, someone has like a certain cookie or cache, not cache, but a certain metadata that shows, hey, they've been looking at this flight for the last 3 months. They're probably going on vacation soon. Reflect the amount of money either to encourage them, like through a sale, or just that you can get like more money, because when I think airlines, I think more like transactional because the pricing is so competitive. Yeah. Okay. So flight should be highly consistent. Pricing is variable. Okay. And I have this information. I'm assuming, and let me know if I'm wrong, uh, um, that for the system, I won't have to worry about like access level controls or user login or like the security information. Correct? It's just we're essentially just building the backend ticketing system to provide this flight information and pricing opportunity. Okay. Hmm. Okay, how to provide the pricing information after. Yeah. Okay. So I'm gonna put that in non-functional requirements. Like, is for the core actions is not necessary, but it's something that would be a nice to have. So personalization of user metadata. Okay, how to provide pricing after search. Okay. So I think I got majority of the requirements. I'm going to do a little bit of calculations after I verify a few, but again, I just want to verify this is the system that you want me to kind of go more in depth in. So my understanding is uh, like a user goes to our site. So let's just say it's like flights.com. They search for two different destination points, so the departure and arrival and certain dates. And from that search, they get a list or a query of search results based on certain criteria, correct? And from that, okay, yeah, okay, so yeah, so from what I've seen on majority like flight aggregators, just again because the airline industry is just so price elastic, um, it's better to show consumers the lowest price to highest price first, yeah, so that actually would be probably pretty useful. In a later point, I'm just gonna like put like a little like flag pin there to probably index part of a database based on that pricing information, just to allow for easier query data. So that's something we can talk about a little bit when we do a little bit of the table design. So table design based on pricing index. And then also based on that search criteria, you can have um, like different filters. So in the search bar you have like, hey, price, highest rated, certain times. So that's just additional query parameters that we can include in our database queries. So I can talk a little bit about that once we start drilling into the high level design. search query parameters. But those common queries come to be like again time based. So 5 a.m. to like 11 a.m. if you like have like certain departure needs. Price based, maybe you want high to low. Maybe you're you know, someone with a lot of money and comforts more of your criteria for buying a plane ticket. Price high to low, and mhm. Okay. All right. So based on that, what you're telling me, then these are probably the two search queries that we want, like either indexed or like cached. Again, just little flag pins for later discussion. And okay, so I think I got the requirements here. I'm just going to do a little bit of math to determine how much latency, throughput, and overall data we're going to probably need over, um, let's just say, like a 5 year time period. So based on five airlines, 100 cities, 3 flights a day. So if you do 5 airlines times 100 cities, that's 500. Times 3 flights, that's 1,500. So let's just do a little text box here. Calculations. So we have essentially 15 flights a day, right? From those 15 flights, I think we can assume uh, with flight information, we're probably gonna need. Okay, so I'm trying to think about it in terms of bytes. So what would we need in overall like flight, and maybe that's where we kind of start having a conversation. Yep, go ahead. Yeah, yeah. Okay, so low latency for user. Okay. Yep. Yeah. Okay. Yeah. So I think I still do want to. Um, oh, I forgot about the seats too. Okay, so good thing we're talking about that, and then seats per flight. So I won't do the storage information, but like essentially what I'm trying to get at is like the throughput, right? So if I know the amount of flights times the seats um, per day, then times that out by a month, and I divide it by 2.5 million seconds, right? Then I'll know the amount of requests I'll be making every single second, right? And then from there, I can adequately decide, what's going to be the optimal database design, and then also what's going to um, uh, uh, be the necessary bottlenecks to address. Is that fine if I proceed with like not the storage calculations, but the throughput calculations? Mm-hmm. Mm-hmm. Exactly. One user that what? Mm-hmm. So for that, I so what I'm thinking is you probably have like a connector service, right? Because if you were to primarily try to do that like through different um, queries on like let's say a SQL database, right? Yeah, it's gonna take a long time to um, aggregate those results, right? Oh, serial users. Okay. Uh, okay. Um, yeah, I mean, if it's just one user, then it's one request per day. I mean, unless they buy, yeah, yeah, yeah. Hmm. Yeah, yeah, I I see what you mean. So if it is like let's say like 15 flights, sorry, 1,500 flights a day, then that's negligible for the amount of like seconds per the day, like you're saying. So the throughput isn't that much of an issue. It's probably the query, like collecting all this data, correct? Mm. Yeah, yeah. Okay, so like this is like where I was trying to go and like my understanding. So let's say that you have like the 1,500 flights a day, right, with all our five airlines, correct? So that's 1,500 flights a day, and then like the average amount of seats on a flight is 100, right? Now, usually, given the airline industry, they have high a selling rate, so they usually occupy 99% of the flights that they have available, those seats, right? They're pretty good at like putting people in seats. So yeah, yeah. Yeah, so you have 15,000 like sales per day, right? From the search queries. Okay, gotcha. Okay, all right. And so for the amount of like purchases, right? That's like not negligible, but the search queries could be like bigger, right? So let's just assume like from those purchase flights, like someone makes 10 search queries before they make a purchase, right? Yep. So then you have 150,000 like search queries essentially before like so for 10 searches, it takes 10 searches to actually get a customer to buy a seat. Exactly. Hmm. Yeah. Yeah, and so like based on like the Pareto principle too. So like just based on the amount of people who actually bought it, like that's 1,500 wait 150,000 search queries, right? And then if you like times that by five, then it's actually five. Sorry, I do simple math. 300, 600, 750,000 search queries, right? So yeah, 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 yeah. So I again, these are just assumptions. Yeah, if we were like discussing this like on our team, we'd have a little bit of more realistic information. But you're definitely right about like not every person who searches buys because I think we've all done the like hopeful searching. Like, oh, okay, I'll plan a trip to Cancun. Okay, so what this tells me is per day, right? So if you times that by 30, let's I'm just going to like round it up to one. So that'd be like 3 million. So 75% of 30 million. So let's just 1 second. Yeah, yeah. Okay. So based on this rough calculation, we have 222.5 million search queries um, per month, and then there are basically 2.5 million seconds in a month. And then, so what this tells us is that, like, roughly we have, let's see, one search query per second. Oh, yeah, roughly around one search query per second. So actually, this. Oh, you're right. Thank you. Yeah. Again, with the simple math, it got me. Okay, so and um, okay, yeah, we have 10 search queries per second. So actually, this is a lot lower than I originally thought. Yeah, yeah. it's not as bad as like something a little bit more highly scalable like Twitter or like Google. I mean, they're a different thing, but this is a little bit more manageable. And even if we take into consideration like a 1.05% growth rate in overall search queries, like year over year, um, we're not in too bad a range for our overall data system. So, um, like what this, yeah, hmm okay, yeah, and then like based on like what we talked about the principle, like two of the search queries are gonna like reflect a purchase, right? So, um, my intuition, what this is telling me is that we can actually probably set up our overall high level design with a SQL database that that's like we can make this pretty vertically scalable. Like compared to a more highly available system like those services we talked about, like Facebook and Google, just because the search queries per second isn't too much, we yeah, like we can make it like vertically scalable before it has to be horizontally scalable, and we don't necessarily need um, like sorry, we don't necessarily need like a NoSQL database like for those faster like search queries. The only thing I can think about is that something that updates quickly. Maybe we could separate out the pricing with like a NoSQL data store, um, because that could like reflect. Um, well, it depends on how much time uh, we how often we change that. So for prices, from my experience on Google Flights, they change like per page load, or maybe like every 4 hours. I don't see them changing in real time, something like a stock market program. Um, would that be a fair assumption to assume that the price updates every 4 hours? hmm Yeah, with especially with the personal metadata. Okay. hmm Okay. Okay. So prices are not consistent. Okay. And then just something I was thinking of too, like where I'm kind of going towards is like SQL and like vertical scaling. But a way we can like improve that high latency is just to have like caching for like the common search queries. So for example, like let's say your next vacation is um, in let's say you want to go to Egypt, right? And you like do that a couple times based on that user metadata. Like those queries would all already be available like in a data store like Redis or Memcache. So I think I got enough information. Would you like me to do a high level design, and then we can hone in on the bottlenecks and improve it? Okay. 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 All right. So for personal metadata, sorry, yeah, for personal metadata, um, uh, I think we could have, huh? Oh, not that the pricing. Oh, the caching. Okay. Yeah. Okay. Sorry. Caching. Yeah. Okay. Okay. Sorry about that. Yeah. So for the caching, I think you could just look at the overall data locations that the user searched for. So let's just say like the last five are Egypt, 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 Cancun, Egypt. Um, based on that user's preferences and their metadata, that they want flights and pricing information cached for Egypt, right? So based on that, we could have flight information, at least the top 20 results for that time, and yeah, for that time, be cached there. And what we so for caching the results. Okay, gotcha. Um, okay, okay, yeah, that. Okay, so from what I'm hearing you tell me, um, maybe like a popular or close to full flight, you could so cache the results. Yeah, so I'm thinking the most popular destinations you could cache. So if we go back to our Pareto principle, like there's probably out of our 100 cities, 20 cities that customers most often look for flights. Um, and based on our underlying database, we could have, or not even the cities, the most common connections. So a common connection could be LAX to NYC or JFK to LAX. And um, based on our user metadata of like what flights are the most purchased, we we could cache those results. So that latency is like really fast. Like okay, um, and how we can improve that is um, based on the user metadata. We can combine like those common connections with the user's location, and then you like nearby users, and we'd probably have like a logical a latitude and longitude data element in our table. But you could do like yeah, and then like let's say that for the sake of this example, you have like 10 people who live in your city, right? And you are the common connection is to like Los Angeles. Um, they they are all looking at that flight too, and so are you. Um, the like as more and more people like start searching that flight, like our system is intelligent enough to like okay, let's move that data result to our memcache data store, right? And we'd have a least recently updated eviction policy. So like if a flight falls out of favor, then that can just be expelled. Um, and but because it's such a common route for those most popular flights, it's going to be probably the most popular to purchase, and that latency will be improved. So I I might be wrong, but I believe that the actual data access from compared to a cache to an actual database query is maybe like 5 or 10 fold. So you're improving the overall data access with the cache. So yeah, that's the way I would do cache results. Uh, Maybe a combination of like your common results. I mean, your common searches, but primarily like a big proportion of that cache is going to be from similar queries on popular routes from nearby users. Okay. Would would you like me to just do a high level design and then we can talk about the bottlenecks? Okay. Focus on caching infrastructure. Okay. Okay. Yeah. Yeah. Okay. So overall, here's what I'm, oops, let me go to draw, and we'll just have this by standby too. Okay. Okay. So, oops. Okay. So what we have first is essentially our client right here. And that's going to be going to essentially our application layer. So if we just imagine this right here, oops, okay. Oh, that's why. Still on. Okay, and then go back here. So we have, oops. So just imagine this is a group of workers in our application layer. Oops. Okay. Sorry, this is a little difficult to draw on. Okay. Yep. And basically, this is where our cache is gonna be at right here. And then I'm assuming for actual information, we have almost similar to like stock information. Like there's a exchange or register that would get that information. So that'd be like an external service right here. So I can put like exchange for like flights here. And that information goes to our actual databases. Oops. Databases right here. And then yeah. So I'm thinking about like the actual information for the flights. So from the airlines, there is probably some API or exchange that we have written to our actual database layer. So yeah. So and the comparison I made to is like the actual stock exchange. So like TD Ameritrade, they don't have the actual stock. Once they issue a stock trade, they actually have to talk to some exchange to complete it. So similar to the airline industry, we make an API call from here. So again, this is our database layer. Okay, so we get this price information, right? And from this, oops. Okay, so we'll call this flights, right? Okay. And then we also have a second. Okay, so we got flights, and then those include information like pricing, dates, and the cache policy comes from your local users. So we'll also have a users database. Oops. Users that interacts. Oops. With this flights information. So this application goes to, oh, actually, we'll probably, no, we won't need a cache there. Okay, so yeah, we got user information. Okay. And then from that user information, like we're saying, that has like local metadata on geospatial information. So based on that, we would have a service that this runs to, right? And then from that service, this client provides information with that like search query, right? So let's say like the information is not in the cache, right? So our search query, oops, goes to query this information from the database. From that database, we return certain results, and based on that, oops, sorry, based on that search query, we note the query, we note the latitude and longitude from that. So we might actually want that service. So nearby. Okay, 1 second. Let me insert a text box. Okay, yeah. Yeah. So just sorry about the arrow, but like imagine before we actually pass that query onto this flights layer, right? We keep track of the user information with that search query, and based on that, when that flights information comes back, um, this this user service gets updated and lets the cache know um, based on it basically updates the cache, right? So with that least recently used eviction policy, let's say you have that popular flight, New York to LAX. Uh, Now the next time, so the first user has to do all the work essentially, or the first couple users, but let's say like the 100th user now looking for that information. Now instead of having to go all the way to this database layer, it's already in the cache based on nearby users. And that's actually processed by um, logic in the cache that says, hey, this is your latitude and longitude. These were the most popular flights for that route. Oops. Okay. So instead of having to go all the way to the database layer, now we just return that result um, to the client faster. So this kind of accomplishes our goal of high latency, right? So um, yeah, and let's just say like a certain like destination comes out a favor, our LRU like eviction policy will just remove that. So as more and more queries are made, let's just say that Dubai becomes a very popular vacation destination from New York to Dubai, right? Over time, least popular routes, let's say NYC to Cleveland, Ohio, that gets removed. And that's all based on this user service right here. So it not only keeps track of the user geospatial data, but that search query. And then if you want, I can kind of go quickly over like what that query looks like. Yeah. So yeah. So it's going to be roughly pseudo SQL code. But yeah. So basically, you would have like yeah. Thank you. Good good call. Okay, so based on that, you just have like a rough like database query, and like where the real magic happens is like before this actual query is sent, we check the cache for that query too. But here is what roughly looks like. Select. Let's just say, yep. Huh? Oh yeah. Okay. So let's do. So select from let's just say like flights. So that's our DB. And then we'll just like do limit 100 because we still want the queries to be pretty fast. So limit like 100 ASC, and then from this, let's just say where lat equals P1 and long. Oops. Oh, this is not capital. Lat and long equals P2. P2. Um, and time date is between two dates, right? Date A, date B. Again, this is just very rough SQL. I know it might not be optimal, like so. Date B, and that these date times also include times as well. So I'll just like do time B and time B. And so based on this query right here, um, we also have included probably a query. From that query, we also have data sent over. So what that metadata would probably look like is user ID, right? So user ID, this is going to be like some type of int or user characteristic, like a maybe alphanumeric. Then we're going to have search query parameters, or actually search query destination departure. Okay. And then the most important part of like this overall, there might be some more stuff, but the most important stuff is that geo is that array or maybe even tuple of lat and longitude. And basically with these two pieces of information, it would first search our memcache data store, and if it was found there, then it would just return that. That reduces the overall latency. If it's not found, then this overall these two queries go through the user service right here, this block right here. No, I can't highlight it, but this little box right here. This second part of information gets tracked, and you make the actual database query. It returns back to that user service. That those results are noted and then put to the data store if enough of those geospatial relationships are found. And then on subsequent queries for different clients, if their longitude and latitude match and it's a highly popular destination and route for future customers, then you're improving that overall latency. Again, because we have such like reasonable amount of search queries per second, I think our overall like SQL database design is fine. Over, yep, yes. Um, yes, yeah, yeah, yeah. So it'd actually be this, and then I forgot to add like the results, right? Yeah, so the results would be from this search query up here. So let me just highlight it from here, and then let's just say, yep, go ahead. Mm-hmm. Oh yeah, yeah. So I apologize for that. So it would be user geo. So yeah, yeah. So user geo. So like again, yes. Mm-hmm. Hmm. Okay, I see the issue you're talking about. So maybe instead of okay, so maybe instead of the user geo, it would actually be route geo. Um, so like we're talking about like a popular yes. Mm-hmm. Mm-hmm. So yeah, so that's an interesting dilemma. I think in order to handle that, like so both benefit would then to be use a combination of both patterns. So not only is it user geo, but also route geo. So if if the members around your proximity are like such um, a highly visited route or purchase route, um, then we also keep note of the departure and arrival city, and then if that shows up enough in the search queries, that gets noted for a route geo. So someone from Toronto to, did you say Berlin? Yeah. They might not be in the Toronto proximity, right, of those users, but they were able to find that route information based on the route geo, right? So it just gets reversed. So I think he would still be able to benefit if you didn't solely make it the cache policy on user geo. It'd be a combination. Yeah. Hmm. Yeah. Yeah. Okay. Hmm. Yeah. 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 So a cache usually is, yeah. Okay. I see what you're saying. So like one of these cache data stores could be in a different location, or not the one that they're particularly applying to. So okay. I'm sorry. Okay, yeah. So um, what we could do. So no, yeah, it wouldn't benefit in that case. There'd be different locations because you have different data stores for different geographical locations. So mhm, yeah, 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 yeah. So so what I'm thinking is because we have like all these different like cache areas, right? You could probably do some replication service that like eventually like updates the cache like for those most popular routes. Now, I'm trying to see what would be the best manner to do that. My intuition is saying like a yeah. Okay. Yeah. Yeah. Toronto. So okay, so you have these flights from Toronto to Berlin, right? But that's only one way, right? Not necessarily bi-directional. Yeah. So mhm. it, I know for a lot of people, well, yeah, it's usually a round trip. Yep. So Yeah, so it's usually round trip. So once you're gathering like that information, you essentially have like two different parts of information. You have like the departure and arrival dates, times, prices. So what you could do is for those return portions of the flight, you could send them to like an updater service, and like based on like the latitude and longitude, and like just update like that yeah, based on the city. Yeah, and see if it's popular, and then as it updates the cache. So like essentially, you don't have to duplicate your work unnecessarily. So for example, that man in Berlin, um, he doesn't have to do that long database query because enough people from Toronto have searched for that return flight, and let's just say that that's like 100. Like it was early in the morning, a lot of people bought flights or like looked at flights. That information has already been collated in the North America cache, right? Then it gets sent to the replicator service uh, some portion of time, maybe every 1 hour, 2 hours, and that gets updated. And because that cache in the EMEA region or Europe region gets updated when that client in Europe searches that particular flight from Berlin to Toronto, it improves that overall latency. So this system design right here, I think, would just be replicated for that geographical location. So you can imagine like the different regions in the world, it have a similar high level design, but what really connects it is that aggregator service based on the half portion of data with the return flight information. So not aggregate. I mean the update service. Um, it would know where to send based on like a pub sub model, and the topics would be based on geographical location or city. Yeah, yeah. Um, so okay, okay. I'm gonna end. Oh, sorry. You mind if I stop recording now? Okay, cool.